Hello, welcome to Sustainable Investing. In this video, we're going to talk about some new research that just came out on the potential for carbon capture and storage to help mitigate and combat climate change. Before we get started, please hit the like button to help support the channel, and if you're new here, please consider subscribing. So a new research article just came out in 2021 titled "A Proposed Global Layout of Carbon Capture and Storage in Line with a 2-Degree Climate Target." This article was published in Nature and Climate Change, a very reputable journal. So in this short video, we'll go over the key points that the article discusses, what their research findings were, and I'll discuss my own thoughts about the article and maybe some points that I disagree with. As of 2020, only about 0.1% of CO2 that's produced is actually captured through carbon sequestration. Our biggest challenge is scale, cost, and getting enough countries to buy in and implement the technology. We need to have a better understanding of where the big CO2 producers are and where are the biggest carbon sinks that could capture and store that CO2 around the world. If we want to limit our planet's warming by 2 degrees Celsius from pre-industrial levels, then we need to capture about 94 gigatons of carbon dioxide by the year 2050. So the objectives of this research paper were to propose a global collaborative layout of carbon capture, utilization, and storage to achieve capturing 92 gigatons of carbon dioxide by 2050. To do this, they constructed a global database consisting of 1 kilometer square grids of carbon emission sources and sinks. They identified 4,220 carbon emission clusters, and they assessed the potential of carbon storage at 794 basins. Their first figure shows global carbon emission clusters. So the larger red dots on the map show areas with greater carbon emissions. And so we see the biggest areas around the world where CO2 is produced are US, China, India, and Europe. This map shows the global potential for carbon storage. So blue areas in the map show oil and gas basins, whereas orange areas are saline aquifers. Areas with large stars show greater potential, and smaller stars are lower potential for storage. The effective global CO2 storage potential is estimated to be about 2,082 gigatons, which is 3 times the amount that the world is expected to produce in CO2 emissions in the next 30 years. Of those 2,000 gigatons, about 8% of the potential is in oil and gas basins, whereas 92% of the potential is in the saline aquifers. The greatest carbon storage capacity by country is in Russia, followed by Australia, USA, Brazil, Canada, and China. According to the IPCC, transportation from carbon producers to the storage location within 300 kilometers is seen as economically feasible for carbon capture and storage. The researchers found that through their global database of sources and sinks for carbon, that about 80% of the matches were within this 300 kilometer radius. Now let's talk about the costs of carbon capture and storage. The researchers estimate that to implement this global layout of carbon capture and storage, it'll cost about $8.2 trillion from 2020 through to 2050. These estimated costs for carbon capture work out to be about $80.26 US for every ton of CO2 captured. The researchers do suggest that this $8 trillion price tag could be partially offset if a big chunk of the CO2 that's captured could be reused for enhanced oil recovery, where the CO2 is injected into the ground to help extract more oil. I have my own issues with this that I'll raise later. If the CO2 were reused for enhanced oil recovery, that could generate $5.7 trillion in revenue, which would partially offset that $8 trillion price tag. So here are my thoughts on the research paper. I thought that this was a really interesting study, and they made great use of the maps and the data to communicate where carbon emissions are coming from and where the potential storage and sinks exist. I do have a few disagreements or limitations that I want to point out with this research article. The first is the idea that the researchers proposed to reuse some of the CO2 that's captured towards enhanced oil recovery. I feel like it's counterintuitive towards the problem that we're actually trying to solve, which is to overall reduce carbon emissions and mitigate climate change. The researchers don't discuss what the downstream emissions would be if you reused that CO2 to basically extract more oil from the ground and then burn that to cause even more emissions to go into the atmosphere. Then you need to capture even more carbon from that, which comes at a greater cost. So I don't know if they accounted for that. The other thing I wish the authors had discussed in this article was the actual methods that can be used to capture and store carbon dioxide. They only talk about the global layout and just generally capturing carbon and where it could be potentially stored, but they don't actually talk about the extraction methods and other ways the CO2 can be reused. For example, I know there's a company called Carbon Cure that literally uses CO2 to create cement. So what do you think about this research article on carbon capture and storage? I'll make sure to post a link to the article that you can read in the video description. If you enjoyed this video, please smash the like button and don't forget to subscribe. Thanks for watching.